Dear students, in this video, I will explain how to make an helical gear, a perfect helical gear using Catia generative shape design. Okay, so this one is a helical gear. Okay, so helical gear is used for high speed operations. Okay, so we can use spur gear. Spur gear is only for low speed operation. Okay, so yeah, helical gear parameters. These are the parameters. So we design helical gear for module 15 millimeter. Okay, so module indicates the gear size. If the gear module is 15 millimeter, medium size gear. Okay, so gear module is 5 millimeter means small size gear. Okay, gear module is 30 millimeter means large gear. So I am designing a gear for module. So first we select module for gear. Okay, and number of teeth on the gear. Okay, 30. So number of teeth, gear teeth, right? So then we can calculate the pitch circle diameter. Okay, pitch circle diameter using this formula, number of teeth multiplied by the module. So here, yeah, module. So yeah, what is pitch circle? So pitch circle is this one. When two gear meet, right? So they meet at a common point. Okay, so circle passing through that common point is known as pitch circle. Okay, it's imaginary circle. Okay, imaginary circle, when the two gear meet, right, they meet at a common point. This circle is known as pitch circle. Okay, so after finding the pitch circle, right, so we can find the larger circle radius. The larger circle radius is known as addendum circle. Okay, addendum circle. So addendum circle radius can be found using this formula. Okay, and you can also find this circle radius. Okay, so dedendum circle. So this one is addendum circle for this gear, and this one is dedendum circle for this gear. For this gear, right, green gear, this one is addendum circle and this one is dedendum circle. So we can also use a formula for dedendum circle, pitch circle radius multiplied by a pitch circle radius minus 1.25 multiplied by module. Okay, and after finding that one, right, so there is a fillet right in between. Okay, so we make, okay, we don't make gears with sharp corners. So sharp corners makes stress concentration. Okay, there, to yeah, we use a fillet to make the sharp corners rounded. Okay, so fillet radius also, there is a formula for fillet radius, so 0.39 times module, and angle between two gears. Okay, here, for example, angle between, okay, yeah, angle between two gear tooth. Okay, there is another formula, right? So yeah, for example, this is one gear. I mean, this is another, this one gear teeth, angle between two opposite sides. Okay, I mean, this another teeth. Okay, so I want to find what is the angle between these two. Okay, like, so this one is 90 by number of teeth, right? So quarter, right? 360 degrees is full circle, quarter circle divided by number of teeth, 90 by n. Okay, so these are the parameters, and we need one more parameter for helical gear. So yeah, so helix pitch. Okay, we need a helix to make helical gear, right? We need a helix. This one, this is in the form of helix. It's not just right line. Okay, it's in the form of curve. Okay, pitch of the helix or lead of the helix, right? So this is the formula. Okay, so yeah, so tangent theta. So pi multiplied by pitch circle diameter divided by, so tangent alpha. Alpha is known as helix angle. Okay, so this one is helix angle. Okay, when you make like this, so angle made by the helical curve with the axis of the gear is helix. For this problem, right, this is 30 degrees, I think. Okay, yeah, these are the parameters. Okay, and face width, what is face width? Thickness of the gear. Okay, thickness of the gear is So 60 millimeter. 60 millimeter. So that is the thickness of the gear. Okay, now first what we have to do, right, for designing any gear, spur gear or helical gear, so we have to find the coordinate points of this gear tooth profile. Okay, a coordinate point, I mean the points on this gear tooth profile. So gear tooth profile can be in the form of involute profile or cycloidal profile. Generally nowadays all gears are following involute profile. Okay, all manufacturers using involute profile for making gear tooth. Okay, so so there is some formula. Okay, I don't discuss all these things. Okay, so based on the pressure angle, okay, there is some formula to create coordinate points. Okay, for involute profile. So yeah, so using that formula, so what I did is, yeah, for example, here gear tooth, right, starting point, that is the tip of the gear, and this one is the base of the gear. So we have a gear tooth, right, like okay, so for example, this one is a gear tooth profile, right, it's involute profile. So I generated a point in between these two. So I generated total 1 2 3 4 5 6 7 8 9 10 points. Okay, so 10 points including this. Okay, so like this, so you can generate as many as points you want. Okay, I think 10 points are necessary. 10 points are enough for this. So I generated 10 points. For example, I'm making the gear on YZ plane. Okay, front view of the gear is on YZ plane. So this one is Y coordinate point. Okay, and height is Z coordinate point. Okay, this one is Y. This one is Y coordinate point for this. Okay, so Y1 for point 1, right? Point 1, and the height, this is a Z1. Okay, so like that we have 10 points, right? So Y10 and Z10. Okay, these are the points. Okay, from the base point I started. Okay, so Y point and Z point. So because okay, and X is 0 for all points because we are making this profile on YZ plane. Okay, so X is 0 here. We can make 0 here, 0 0 0. So first what we have to do, we have to input those points. Okay, so you can create a file using some software. You can create a file and we can input that file. Okay, you can copy that file point data to Excel sheet and we can import that one directly to the Catia. So otherwise you have to input one by one. Okay, you have to input one by one. So here I input one by one. So I also provided a video how to input several points. Okay, directly from a file to Catia. Okay, so we should start generative shape design or wireframe design. You can choose. So name the part. So name the part. Okay, and I'm deleting all the, yeah. So on YZ plane, I'm inputting point, right? So select this point tool. Okay, now double click on the point tool to input many points, right? Double click. Otherwise, you have to select one by one again. The first point is this one. So first point, right? Okay, X is 0 and now copy that one. So first point, X is 0 and Y is 0 and Z is, okay, Z is so 211.43. 211.43. Yeah. So first point, you can see that is the first point. Okay. So second point is, so X is 0, Y is 0.047. 0.047 and 047, not 47. So be careful. And Z is 212.23. 24, 212.24, no, 24, okay, that is second point. And third point is 0.385, 0.385, 385, 385, and Z is 14.69, 14 to 14.69, okay, and Z 1.346, so 1.346, 346, and 218.88, 218.88, and 2.187, 0.187, and Z is 221.68, 21 point. So if we have many points, right, inputting like this one is difficult, right, time consuming. So you should load this data to Excel file. And okay, so what I 21 point Excel file and import the data to Catia. So 3.35, okay, so 3.35 and 224.975, 24.975, and 4.92, 4.92, 228.79, 28 point. I just used 228.879, right? So 220.79 and 6.99. I just use 7 here. 7, 6.99, right? 7. Save time. And 233.2, 233.18, right? 2. So 9.675, 9.67, and that is 238.16. Okay, and the finally 10.6 tip point or addendum circle point. 10.6 and 239.76. Okay, so these are the 10 points. Okay, these are the 10 points. So next, what you do, right? We join these 10 points using spline, right? Spline. So in an order, okay. So from the top to bottom or from the bottom to top. So select this point and this point. Okay. Okay, click on OK. So that one. So remember the pitch point is, remember this one is pitch point. I think so pitch point is, we need that point. Okay. So pitch point. So 3.35 and 224.975. This one is pitch point at an angle 20 degrees, right? This one is pitch point. So where the pitch circle is passing through. 3.35, and remember this one. And okay, I think this one is pitch point. Okay. So point A, 1, 2, 3, 4, 5, sixth point is pitch point. Rename that one, right? You can rename, or if you want to keep the same. Okay, sorry. Rename, right? Properties. So PI point. Okay, and you can hide all these the points, right? Except if pitch point, you can hide. Yeah. So now the same curve we have to mirror to the opposite side. Okay. So I made one side curve, right? I say I made one side curve. Okay, I made this one, right? You have to mirror this one to other side. What is the angle? The angle between two opposite teeth, right? To 90 by number of teeth, right? You can use that formula. Okay. So the angle between two opposite sides of the 3 degrees. Okay. Yeah, but you know, this one is a 3D, right? We have to create a plane, right? Create a plane. So with respect to this plane, ZX plane, we have to create a plane such that it makes an angle, right? Angle normal to the plane, right? Rotation axis is, so x-axis, so angle is 3 degrees, minus 3 degrees, clockwise, right? So rotating clockwise, okay, here, rotating clockwise, minus 3. And now we have to mirror, right? So mirror, symmetry, use symmetry. So what is the plane? Yeah, plane we created, right? So that side, another side, okay? So that one is, so you can do all these things in 2D also, okay? You can do all these things in 2D. So create points using coordinates, and but 3D I'm doing, right? So you can hide this plane, okay? A pitch point. We need pitch point to start helix, okay? And now, okay. Okay, now, so what we have to do, we have to make a circle, okay? Base circle and make fillet here, and we can make top circle and make fillet, okay? Okay, so yeah. So make circle, right? I'm going to use 3D circle. You can make a 2D circle also, okay? In sketch wise. So 3D circle, what is the base circle radius? Base circle radius is yeah, this one 206.25. Addendum circle, pitch circle radius minus 1.25 times 206.25. So where is the circle? Circle. You can make half circle or full circle. Okay. So we can make full circle, no problem. Center is center point 0, 0, 0. Right? Create a point. We don't have 0 point, right? 0, 0, point, center point, right? So support the YZ plane, and radius is 206.25. 206.25. Okay. Yep. And yeah, so we have to make a fillet, right? So fillet radius. So this is the formula, 0.39 times module 5.85. So we are making the fillet in 3D, right? So here, this one, 3D corner. Okay, below the circle we have 3D corner. So corner on support you can choose, and trim, you choose trim element. Okay, trim, and the element, this one is the first element and this one is second element, and radius, the first set the radius. So 3.85, 5.85, sorry. So 5.85. So second element is this one. Okay, yeah, okay. Okay. Corner on support. Trim element to element one. Okay, just so trim only this one. Okay, so trim only this one. We don't need this circle actually. This one we can. So trim element only this one. Okay, only this here trim. Okay, and again you can make this one right other side. Actually, this one delete, right? Symmetry one delete. Okay, yeah, here delete this one. You can do it again. Okay, this you can hide this one, hide. So select this one and this one and this one. All, select all. So symmetry about actually after doing all, right, better to mirror. Okay, symmetry after doing trimming and all, right. And now we have to connect this one using a circle. We have to connect this one using a circle. So this circle is addendum circle, this circle is base circle. So addendum circle radius is addendum circle radius 40 millimeter. So you can use this circle option, circle option, right? So not center on radius option, only a portion I have to connect, right? So 2 points and radius, 2 points and radius. So point one is this one, and point two is this one, and radius is 240. 240. Support is YZ plane. Support is YZ plane. Okay. Yeah. So it is providing two solutions, right? So the bottom one is correct. Okay. Yeah, this one is correct. So this is the bottom one. Click on OK. Okay, not full circle. Yeah, we can make arc. Okay, actually, so not full circle. So same arc. Okay, actually not full circle. So this point and this point, and support is YZ plane, and radius is the dedendum circle radius 206.25. So 206.25. Yeah, and the same, it is providing two solutions. One solution is this one, and another solution. So the blue color one is correct. And next solution, this one is correct. Arc, you should check. Okay. And now we have to join all this one, right? This one is get to profile, right? So join this one and this one and this one, except points, right? Join all. So these points are for starting the helix. Okay, these points for starting helix. Click on OK. Okay, so now, yeah, for spur gear, this is the process. Okay, for spur gear or helical gear, until this process is same until here. Okay, until here the process is same, but for helical gear we should use sweep with two guides. So the guides are two helixes. Okay, one is here and the other one is here. Okay, so we have to make helix, two helices, okay, not single helix. So then we use sweep with two guide curve option. So helix, we can start helix, right? Where is the helix? Below the spline, we have helix. So starting point, so either this one or this one. One is here, and axis is the what is x-axis, right? X-axis towards me, right? That is x-axis. So yz plane, right? This one is yz plane. And pitch, as I said, right? Pitch, there is a formula for pitch. So lead actually. So 2448.629. You can copy that one. Yeah, pitch. And the height. Height is the width of the gear, 60 millimeter. You see the height. Height is thickness of the gear. So 60 millimeter, 60. Okay. So, but it is giving the helix the front side, reverse the direction. Okay, reverse the direction. So counterclockwise. So click on OK. Yeah, same here. Another helix, the same processes. So helix is different. You don't mirror, right? Symmetry. If you do symmetry, it gives another solution. It's not symmetry. You have to make two helixes. X-axis and same, pitch is same, and height is 60 millimeter, and reverse the direction. Click on OK. Yeah, now what you do, now we don't need this pitch point, okay, hide, and we also don't need this hide. Okay, so what I need only this profile, right? You join, right, that profile. So that one you have to join all before making it. Now we should use the sweep option. So what I'm going to use a sweep. First I'm creating surface, then I do remaining things in part design. Okay, not here. You can do here, but you know, making the remaining things is easy for me in part design. Okay, making hole here and all these things are easy for me in part design. Okay, so yeah, guide curve. So with the two guide curves, second option. Sorry, the second option. So with the two guide curves option. So profile is the helix and guide curve one is, sorry, profile is the get to profile, and guide curve one is helix one, and guide curve two is helix one, helix two. And yeah, so spine is x-axis. Okay, so then point is touching here, right? If spine is different, automatically calculating, then you will get wrong profile. Okay, so spine is x-axis. Click on OK. Okay, now what you do, I don't need this now. Helix hide, you can hide, and helix hide, and join, you can hide, profile, you can hide. Yeah. So go to part design, mechanical design, part design, and yeah, in part design, use the fill surface, the closed surface here, in surface based features here. So object to close is this one. Okay, now this one is outer layer, you can hide, and you have to pattern this one 30 times. There are 30 number of teeth, right? So pattern. So instances, so 30, and the angle is, if there are 30 tooth, right, 360 by 30. So 30 degrees angle, 360 over 30, or you can calculate, right? Input that one. So 12 degrees angle. And reference element, right? What is the reference element? You can choose the YZ plane, center of the YZ plane, or you can choose the x-axis. You can choose the YZ plane, or you can choose an x-axis. Okay, some warning is there, right? Yeah, current solid, object to pattern is only current solid is nothing but only this one. Click on OK. So now base circle you have to make right here on YZ plane, or you can make here. Okay, we can make I think this one here on YZ plane. Make circle, base circle. Yeah, we already have base circle, right? We don't need to make the base circle. What is that one? We have the circle, right? We already have the circle, that is the base circle. So you can pad, right? Pad. So this one, circle one is nothing but base circle, right? We already made. Or if you want to make again. Go to YZ plane and make. So pad thickness is 60 millimeter. So gear to width of the gear is okay. So now this one is perfect helical gear. And now what you do? So we have to make this one. We have to make this one, right? So make this one. So for that one, we use axis here, okay, and make this one, okay. So yeah, yeah. So here on YZ plane or here, make sketch. So yeah, make this line. I make this line. So make this line. Make this line. So the radius of this one is 130. Okay, 130. So angle is 15 degrees. Angle is 15 degrees. Okay. We are going to use cylindrical elongated hole. So clear all my drawings. Okay, yeah, here. So axis you can make so starting from 0, 0 angle. So radius of the line is 130. So radius of that line is 130. So 130 angle is 15 degrees. Okay. Yeah, 15 degrees. So one more line, one more axis. Okay, the other side. So starting from 0, 0. Okay, it's not touching. Okay, so the angle is same here. 30. Sorry, 15 degrees. So 15 degrees and the length of the line, right? Okay. Yeah. The length of the line is also same 130. Actually, you don't need to specify that length. Okay. One is enough. Okay. So one is this one, right? So now we use this tool, the cylindrical elongated hole. Where is that one? Below the rectangle. Okay. This one. Cylindrical elongated hole. Center point of that one is this one, and starting point of that one is here because I define 130 here, and ending point is up to this axis. Okay, and so radius of that one is 30. So I define these lines, right? These lines to start this hole and end this axis. Okay, and now you can make pocket, right? Up to last, or you can give 60 dimension. Okay, and yeah, pattern that one. So pattern. right? Circular pattern. So instances are 3, and if instances are 3, angle is 120 degree, right? So reference element is x-axis, or select this plane. Okay, reference element x-axis. You can select YZ plane. Okay, you can okay, and now we have to make this shaft. Okay, this shaft. Yeah, 140. Yeah, 140. So it is 60. So remaining is almost 80. Right? Yeah, 80. So this one is 40, and this one is 40. So 40 plus 60 plus 40. Okay, we can make this circle. Okay, you can make this circle. Okay. Yeah, make the circle where on YZ plane, or okay. So sketch, right? Make circle, right? So the shaft diameter is 160. So diameter is 160. I think not 100. Oh, sorry, 100 and 160. Diameter 160. I think that is correct. 160. Okay, so pad. Yeah, one side 40, front side one more, right? So back side is 60 plus 40, 100, right? So pad like this one, and yeah, finally we have to make a hole. So doing these things, right, in part design is easy, right? That's why I'm doing all these things. So we have to make this one. Okay, so the circle diameter is 120, and keyhole size 18 to 16 millimeter. What is 18 to 16 millimeter? The height is 16 millimeter, this height, and this depth is 8 millimeter. Okay, 8 millimeter. Okay, so yeah, so make here circle with keyhole. Circle radius is diameter 120, and keyhole, to make keyhole I use this rectangle, center rectangle. So here, so height of the rectangle is 16, 18 to 16, right? 16, and the middle from here to here, right? This is 8. So 8, and you have to erase, right? So we have to delete. So this portion we have to delete. Okay. So finally, what we have to do, we have to pocket that one up to last. Okay, last. And there are some minor things to do. Chamfer, right? C2 and radius fillet are fine. Okay. So here chamfer. Yeah, chamfer. Yeah, I am using zoom, right? So mini tools here. Okay. Obstructing. Okay. Chamfer. Yeah, both sides. Right? This side. So 2 millimeter, C2. Is it 2? No, C2, and fillet here, and this side. So fillet. Radius 5 millimeter. Okay. Yeah, this one is the final one. Okay, little gear. Hope this is helpful for you. Okay, thank you. Yeah, you can so see this helix angle, right? Helix angle should be 30 degrees. Okay, 30 degrees. So you can check that angle after finishing. Okay, thank you.